So, breathing. We as humans breathe and lichens also breathe, but it really matters what we breathe. All over the world, there are 4.2 million premature deaths due to air pollution every year. And therefore, air pollution is the world's most serious environmental health risk. So last year in end of May, Edmonton had one of the worst air quality scores of all bigger cities in the world due to wildfire around the city. We cannot change anything about the wildfire situation here, as they are just naturally occurring in this region. But however, very likely they will increase in severity and in frequency with ongoing climate change. But poor air quality does not only harm us as humans, it also impacts the natural environment around us. So if I say natural environment around us, what's that? So I just threw in some words on this slide for now, but they will play a role later. And then you will realize that it's not coincidence that I've chosen these words and these factors, as all of them have to be found to impact lichen diversity. So, but first, maybe you might ask yourself, what the heck are lichens? And I can tell you what they are not. They are not plants. And here are some of the lichens found in Edmonton. Spoiler alert, there are over 100 different lichen species around Edmonton. On the left, these are some of the most common lichens found in Edmonton. And on the right-hand side, this is a lichen that is pretty much restricted to the river valley. So you already realize that there are certain patterns of differences in distribution. In general, lichens are a symbiotic partnership between one or more fungi with one or more photosynthetic partner, often an algae. So this is basically the algae is the picture that you see in the middle. Some lichens can actually photosynthesize just with ambient humidity. A plant cannot do that because they need liquid water, and jelly lichens, for example, can also not do that. And this is why they are just barely found in Edmonton due to the low humidity here. And here comes the second most important thing that you should know about lichens, other than they are not plants. In contrast to most plants with a vascular system, lichens just directly absorb water and air, and so they are not able to isolate dissolved harmful pollutants. And this is actually why lichens are very sensitive to air pollution, and therefore are very good multi-year bioindicators. And if I say multi-year, it means they are around. They are available for us all year round, spring, summer, fall, and winter, which we'll actually see later. And once a lichen has settled down, it stays there. They can literally survive for decades and live on substrates that most things just cannot live on. For example, also, like an old boot or something like that, or stones. So talking about decades, let's dive into history. And historical background, first research, let's call it research or observations that lichens are related to bad air quality took place in Europe in 1866, so over 150 years ago. And here in Canada, more recently, there have been other studies, particularly in Eastern Canada, 2009, one in Hamilton, 2012 in Ottawa. And our key question now was, can we also use lichens as biomonitors in Edmonton, which you know and you experience every time, extremely cold winters, very dry climate in general, and most of the lichens actually prefer moist conditions. Okay, so to answer these questions, teams of lichen specialists and students went in the freezing cold of an Edmonton February to sample and record lichens around the city. So my job for this summer has been to implement all this data that they collected in a geographic information system and analyze it together with other available data set. And I have to say, one side note here, me coming from Germany, I was absolutely amazed and impressed by Edmonton's open data approach and open data sources that you guys have around here and what data is available to you. That's amazing. So this is a map of Edmonton, and we can see that lichen teams followed a sampling grid of 1.5 kilometers between each grid point, mostly within the Anthony Handy Drive. And the green stars here on the map are all our sampling sites, 191 in total. So here we can have a look on one of example data sheets, the surveys that the students filled out. So when they went to a site, they approached 5 trees on the site, except one exception. If the site was close to air quality measurement stations, of which we have 7 in Edmonton, we sampled 25 trees just to, find, be able to connect some, better correlations later on with air quality parameters. So on each of these 3, the students and lichenologists recorded all the species for all 4 directions, north, east, south, west. And this way, each tree was assigned abundance scores from 0, being not present, to maximum 4, as there are 4 compass directions as far as I know. And then 5 trees per site lead to a maximum abundance of 20 per site. So with their field results, I was able to calculate lichen indices, of which there are plenty nowadays. But now one moment of Canadian pride, it was actually in Canada in 1970, where 2 researchers developed the most well-known index, which is only based on lichen abundance and ecological sensitivity of the individual species. That is what you see in this magic formula, the so-called index of atmospheric purity, or in short, I will refer to it as IAP. As I say, only lichen data goes in there, although it's called atmospheric purity. So let's jump a little bit into the results. And for some of you lichen lovers already, the most common species, there were 2 lichen species in Edmonton that were almost like the superwoman and the superman amongst the lichen species, as they were present at every single site. Xanthomendosa phallax and Phaeophyschia orbicularis, if that was wrong, Diane can correct me later on. And these were actually really present in every site. And at, let's say, worse sites, or like sites where not that many lichens were present, like in Edmonton central downtown area, it was almost only those 2 species. From now on, whenever you take a stroll throughout Edmonton and you can have a look on the bark of the trees, it's very likely that you actually find some of these species, and then you, as a well-informed citizen scientist, can actually tell something about that already by now. So let's maybe that's also very interesting for you. My results as a map. This map was done using interpolation with inverse distance weighting, which gives the closest data points a higher weight than points further away. And for this map, I interpolated it in the way that 20 data points, so 5 trees, 20 trees in total, 5 sites were included. And we see low index of atmospheric purity scores in the high density downtown area up to the Yellowhead Trail, and higher scores in the green areas around the more natural, less dense area around the White Mud area. And now to the key question, basically, what is driving the red and what is driving the green areas? What's behind it? And why is downtown a lichen desert? And why are there more lichens around the river valley? So from past research, we know that the red areas have been correlated to bad air quality, and vice versa, of course, valid then for the green areas. But is this actually the case for Edmonton? So more recent research has actually shown that the so-called index of atmospheric purity does not really hold what its name promises. So it was developed back in the days when sulfur dioxide, as a byproduct of many industrial combustion processes, in particular in the 80s, was a big issue. And then with filters for many of the coal power plants, we actually solved that issue, and also issues of acid rains back in the days were an issue. So historically, the main research focus and the strongest correlations of the atmospheric purity index were found with sulfur dioxide concentrations. And as sulfur dioxide became less and less of an issue, the research actually shifted towards other areas. And with that, in the 2000s, there was a shift from taxonomy-based measures like the index of atmospheric purity towards more functional groups, which rather classify lichen species according to their traits and how they react to specific environmental variables. A little bit later on actually the index, as we already feel, is definitely driven also by other environmental factors other than air quality. Change the slides. So we analyzed other covariates such as land use, moisture regime, or vegetation cover to see what the influence of the surrounding vegetation cover or different moisture regimes have on the lichen assembly in Edmonton. And we were not sure what was the most appropriate scale for which the covariates would still respond. So for some layers, we just suggested different buffer sizes, which you see here, 100 meters, 500 meters, and 1,000 meters. So now I just want to show some quick maps to see some of our observations. This is a traffic map of Edmonton, also used, also some interpolation applied here. So we see in particular, in terms of traffic counts, the Anthony Handy is very busy. Of course, also the Yellowhead Trail, you also see some orange, red areas around Calgary Trail, but it's definitely not that the downtown area is completely red or orange, like you have seen it in the map of the index of atmospheric purity. Another factor here that is land use, and I marked in green the non-developed areas, whereas the developed areas. Non-developed means natural plus modified areas. For example, here you might recognize the old Edmonton Airport. That is still classified as non-developed area, although there is not much of nature going on there, I suspect. Here, the vegetation cover, which looks like fingerprints, but in black, you basically, so you see circles, because of course that's a buffer zone. In this case here, 500 meters. And everything marked in black is then basically a tree or the tree canopy. And you already see some very dark spots around the river valley, which definitely points us towards a more natural environment and also more trees. And with more trees, of course, also more available lichen habitat available. But we definitely still have some trees downtown as well, right? So that is probably also not the reason why we see these red values of lichen deserts around downtown. Moisture regime as a second one, it shows a similar story, right? We see some hydric moisture regimes around the river valley, which then, of course, indicates that we have higher relative humidity in these areas, and that is something that most of the lichens definitely like. Okay, talking a little bit of stats here. Because of the unknown intercorrelation between some covariates and also the fact that we have different buffers, like, traffic counts, road density, definitely correlated with each other, right? So I carried out a redundancy analysis, which considers the complete and original species assemblage. So careful, not the index calculation according to the formula that you saw early on, but really the raw species assemblage, multidimensional analysis. And this species assemblage is then run against every single covariate, and this is why we call it single term redundancy analysis. And then I compared the different R-squares against each other to figure out, okay, what is more correlated than others. You see here, like I marked what I really found interesting, what is kind of the main telling point of my story here is that the really more disturbance related covariates like road density and traffic, so really human disturbance, and is higher correlated to the 100-meter buffer, and more habitat related covariates like land use, tree canopy, moisture regime actually finds higher correlation with the larger radius of 1,000 meters. Still, we find the highest correlations with the air quality parameters average sulfur dioxide and the average NOx around the city of Edmonton. So we see already with these other variables besides air pollution, there is something else driving this lichen assemblage that we have sampled and that we have found. Let me jump one more slide here. Just some easy scatter plots. And so what I did, just to point out those higher correlations that I found and put each of them plotted then against the IAP. So this time against really the index of atmospheric purity, because it simplifies and summarizes the lichen assemblage in a really nicely way. So it's a bit easier to find better correlations. And this is then just done with linear regressions and of selected covariates versus IAP scores. And we definitely see that the data makes sense. I mean, here for roads and also maximum traffic counts, we see a decrease of the IAP scores, the higher the values are, and vice versa is then valid for the moisture regime. So wherever we find a higher moisture regime or a higher percentage of moisture regime, we would find higher IAP scores. Again, vice versa, then it's valid, of course, for the air quality parameters in yellow here, negative correlationships with the IAP. So definitely, as expected, we still see quite low R-squares, which for us is a sign, okay, just multiple factors driving the lichen kind of response that we see around the city. Okay, one more, maybe to the takeaways first. So as I said already, I can only repeat myself one more time. Lichens are not plants. Being aware of this fact, lichens can be monitored by citizen scientists, and lichens are composite indicators and react to multiple things in the environment. So I already pointed out one conclusion, right? It could be, our data shows, similar as in Europe, that we should rather focus, if we want to improve the natural environment around us, on smaller and less densely vegetated green spaces, rather than focusing on the already green areas like the river valley. You can improve a lot by just upgrading like, let's say, problematic areas where there are at least some trees, and you will definitely see some response and hopefully also some improvements in air quality if you upgrade small protected green spaces within the city. So this is from Kevin. I'm not really sure whether he's in the Zoom meeting already. I didn't see some of the Zoom meetings earlier, and he definitely helped us with the data as well. And he brought in one really interesting factor as well that I didn't think of first, temperature. So recent research has actually shown that lichens can also be used to monitor the effects of climate change. And for this, lichen research already moves away from taxonomy-based indices like the index of atmosphericity towards more trace-based indices. And what this slide of him here shows is that if certain relative humidity requirements are met, then according to this very complicated formula, it looks complicated, but they are just some covariates, bunched, put together in one formula. We see LU here as land use, NOx is again the NOx average, and particulate matter here. So different, mostly air quality parameters together with MR, that's moisture regime, are driving the lichen response together with temperature as well. So you see that this graph obviously shows nicer correlations. If Kevin is later on here, he can definitely comment on that. It's just that this is mainly his work, so I don't take the credits for that, but he already has a PhD, so he is a data magician. use this cubist model, and that is sort of also what we still want to look into. This is kind of like a running project that we want to publish later on. So definitely still some things to look into at a later stage. And maybe to point that out as well, like, because we obviously still have some questions, right, on this. So also to just look into the temperature effect and to figure out also why is there a lichen desert in the downtown area. Having read a little bit about the research on lichens that is out there, there is a thing called urban heat island effect, and that is known in like really highly density, like highly urbanized and high density areas where there's just not enough vegetation cover around, there's not enough wind transporting the heat away, so that you have really higher temperatures and lower relative humidities in these areas. And that is, it could be, in my opinion at least, could be one of the effects that we see why we have these red areas of low lichen scores around the downtown area. And with that, we can actually check, even with our data set, we can just also calculate other indices than the index of atmospheric purity that we saw, changing from taxonomy-based indices to traits-based indices, which then means we explicitly check the species, the lichen species that we know that are resistant to warmer temperatures and kind of like low relative humidity, and see, okay, how are they doing in this environment specifically? Yes, and now with our results, of course, we can inform policymakers to keep Edmontonians healthy and to show where the places of environmental concerns are, particularly for lichens, and how we can actually improve that. And with this, I want to open up the round to the discussions. I don't know, maybe Kevin is in there as well. If not, I want to acknowledge his work as well here. Part of the data analysis was done by him. And a big thank you to my three mentors, Kevin, Danielle, Diane, for their ongoing support. Spoiler, but probably Julie will mention that later on. Diane will be leading the lichen walk on Saturday. So if you haven't registered for that, please register and come out. And then last but not least, a big thank you for our today's sponsor, the Edmonton River Valley Conservation Coalition, which is a sponsor of today's event and supported with donations. All right, that's it for now from my side. Are there any open questions?
Hi, Christopher. I have one. How rapidly does lichens be affected by the environment?
Okay, so for all lichen questions, definitely Diane, you are allowed to jump in. But from what I know, lichens, as they are perennial, so that means they are, they are long-term living beings. So that means they sit there for a while and really bioaccumulate all the pollutants over a certain time. So it definitely then takes a while until you see responses. But we know from the literature that some extreme events, like we see in the wildfire, or just really high particulate matter, and in the past also for sulfur dioxide, can cause dying of lichens. And I think some of these effects we still see around the old airport that I showed earlier in the map, that within this area, although there's not that much going on anymore, we definitely still some effects on the lichens there, as they are just not there, or some of the species are no longer there. And Diane, if you want to add on that, feel free.
Hi, Chris. Thanks for the question. Can you hear me okay?
Yes.
Okay. Yeah, it's a great question. And Chris hit a lot of the really important points there, in that you can have a really extreme event that can knock back lichens and kill lichens that may have lived for decades. And then they'll slowly reestablish themselves again. So it just kind of depends on the intensity of an impact. They can withstand depending on the species, years of gradually accumulating heavy metals or nitrogen oxides or sulfur dioxides. And some species are really sensitive, and some species can just persist, like the super lichens that Chris was introducing.
Diane, do you, I tried to explain it a little bit with functional groups and taxonomy groups, but as you're the specialist, you want to take over that as well?
Sure. So taxonomy is just our classification system to kind of try to understand different evolutionary units. So like humans are an evolutionary unit and we're called Homo sapiens. Well, lichens are kind of cool, actually. They're not all one related lineage. They're actually more of an ecological group. Different fungi throughout history have evolved lichenization as kind of an eating habit. So they're not all related to each other, which means that they're pretty variable in their tolerances. So that's the taxonomy side, is that the genus and the species classifications that we give them, and that tells us who's related to who. But the functional classifications get more at that sensitivity. And lichens are because they're so diverse, some are growing with a blue-green algal partner. And if you've heard about blue-green algae, you probably hear about it in a lake, right? A blue-green algae warning, and that is it's overgrowing and it's toxic. Well, some lichens can grow with blue-green algae, and they look like seaweeds almost on the trees. And they happen to be very, very sensitive actually to pollution, kind of ironically. And then other lichens, they grow with green algae, and they tend to be hardier. They can photosynthesize and make sugars just with ambient humidity. So you get this really cool diversity of reactions within this kind of artificial group we call lichens. You have the taxonomy side and then the functional side.
Excellent. Thank you, Diane. That was definitely better than I could have done that. And I just see your lichen walk on 22nd of August is already sold out.
Hi, Chris. This is David here. Can you hear me?
Yes, I can hear you.
Very good. Thanks for your presentation. If you could quickly scroll back to your spatial map with the traffic volumes. Yeah, so with that chart, as well as with your, you don't have to scroll to it, but with your correlations, you had shown that traffic volumes and air quality were strongly correlated with the lichen health index or whatever.
Yep.
And I often think that traffic and air quality are collinear with each other. And so I wonder what other mechanisms you might think of besides air quality or emissions that traffic might impact on the lichens, their health values and their observations. Besides air quality, like what other than air quality might traffic have an impact on?
Not 100% sure whether I understood the question correctly. So is your question more like what else is driving the lichen response, or like what other effects does the traffic have on the natural environment?
Second one, yeah, like what besides air quality might traffic have as an effect on lichens?
Okay, so from what I know, it's not only deposition as gas, as exhaust, but it's also that like I know from my research area where I study in really remote northern peatlands that already just the road and what's coming out of the brakes. I mean, I'm not a engineering guy for cars, but the rubber from the tires, for example, as well, right? They like some of this rubber from the tires sticks to the street, obviously, so that we have more grip. And with rain, that's washed away, and then that also just goes within the natural environment around us. I have to say that the radius is then very, very low, right? That is what we've also seen in data, that at least for the streets, the lowest radius, 100 meter, was the one with the best correlation. But we see that in these northern peatlands a lot, that we see in the peat and in the soil around some signs of phosphorus and other nutrients that then actually can stimulate, but they can also harm the environment around that. And I mean, Diane, you can jump in if you can think of other effects on the lichens, as I'm again not the lichen expert. But there's not only gas exhaust, there's also just the fact that it's also like causing some acids going out of the exhaust as well in a different way, which can definitely harm the lichens as well, I would say.
Yeah,
And
Chris, there's also the just the physical dust that gets from salt or gravel or dirt on vehicles that'll coat the lichens, and that will impact their ability to photosynthesize. There's likely also a microclimate effect. So the trees along the sides of the roads are probably exposed to, more airflow and higher temperatures than those in the nice nested little river valley. So it's just a harsher environment for them all around, which is why on our surveys, we actually tried to pick a location close to our site point that would show the best of the lichen community. So we avoided bus stops, we avoided corners with stop signs, we avoided 2-lane streets. So we were kind of trying to get the best depiction of lichen health and diversity we could.
Does this answer your question, or is something?
That was well said. That's great. Thank you.
Okay. Great. Thank you for your question. Okay.
Well, I've got a question then, while others are thinking of theirs, is you talked about the value of improving small greenland spaces rather than focusing all of one's environmental efforts around large green spaces like the river valley. Just wondering if you could dive into that a little bit more in terms of like how small actually makes a difference and what are the types of actions that a person might want to consider.
Okay, so what I've seen in the data is that mostly the habitat-related covariates like tree canopy cover, moisture regime, those are the ones that really have like a large effect. And this is what I mean when I say, okay, let's also focus on the small areas and not only focus on the areas that are already kind of like natural, but to give lichens some space and give other species, not only lichens, some space, try to upgrade and try to, for example, improve or increase the canopy cover, keep old trees, for example, as well. That might just help from the habitat point of view, so that now only talking about lichens, that lichens have the opportunity to settle down and also to spread over the cities. And that is why those microclimates, maybe Catherine has a comment on that too, from her side, from the city of Edmonton, why these microclimates are actually also very important within a city, to exactly avoid probably what we are seeing in the downtown area, this like heat island effects, that you just really don't have enough natural elements around you. Dr. Greg King was talking about that for trees, I think 3 weeks ago in his presentation, how important trees are from a microclimate perspective in an urban area. So like that is like kind of the message, and that was also shown in other research in Europe, in Lisbon, where the data showed, okay, just by improving the small areas, or like by upgrading the smaller areas, that has a larger effect than like focusing on the large areas that are already very natural. If that answers your questions. And again, my colleagues are very welcome to jump in again.
Yeah, thank you. That was helpful. Yeah.
All right, cool.
Are there some more questions out there for Christopher? While more people are thinking about their questions, I will say that I did post to the chat a post-event survey, which you could fill out anytime during this recording of this webinar session or during the community science session later. And like Christopher pointed out, the lichen walk for Saturday is sold out. But if you'd like to get on the waiting list, you can certainly email us at connect@tomorrowfoundation.ca. And then if somebody is unable to use their ticket, we can let you know. Are there any other questions around lichens? Okay. Well, with that, I'd like to thank you very much for your presentation this evening. I've learned a lot, and I think we maybe perhaps have a few more things to think about as we carry forward in our community science endeavors around air quality. So yes, I appreciate you sharing your knowledge with us.
Well, thank you for the opportunity to present with you, and also thank you for the Tomorrow Foundation. Just by providing that network, and for example, how much Kevin McCollum from the air quality site has helped us, just by establishing the network and by just running these events. I think you already helped us a lot, and I think you're doing a great job there. Thank you.
Wonderful. And just so everybody knows, the presentations that Christopher referred to that we did over the summer, I've also posted links to those in the chat. So Dr. Greg King's as well as Kevin McCollum's presentation. And I would also like to thank the Edmonton River Valley Conservation Coalition for their sponsorship of this event, as well as Saturday's event, and their link to their websites in our chat. So with that, we'll end this portion of the evening.